press the bell icon on the YouTube app and never miss another update.
Hello students, we continue the same concept what we discussed in the last class. Okay, means left hand limit and right hand limit. Once again I explain, when we are finding left hand limit and right hand limit, correct? So if for left approaching and right approaching, the functions are different. In this case only we are finding left hand limit and right hand limit. So left hand limit and right hand limit, both the values are same, then only the limit value exists. Otherwise limit value does not exist. Okay, so we continue the next problem. Next problem is very important problem. Observe here. Suppose, so he has given a function f of x is equal to a plus b into x. X is less than 1. 4. X is equal to 1. B minus a into x, x is greater than 1. So and one more he has given, if limit x tends to 1, f of x is equal to f of 1. This is given. What are possible values of a and b? What are possible values of a and b? Observe, he has given f of x, a plus bx for x less than 1, 4 for x is equal to 1, and b minus ax for x greater than 1. One more condition he has given, limit x tends to 1, f of x is equal to f of n. Under this condition, what are the values of a and b? Means in this problem we are going to find what? The values of a and b. We are going to find the values of a and b. Okay, so given, we write given f of x is equal to a plus bx for x less than 1, 4, x is equal to 1, b minus ax for x greater than 1, and limit x tends to 1, f of x is equal to 1. So better I draw the number line also. No need to draw the number line. For better understanding, number line. Okay, so number line, it is from minus infinity to plus infinity. Okay, the domain is 1. The domain is 1. So in this case, observe here, for less than 1, so f of x, a plus bx right here, and x tends to 1, f of x is equal to f of 1 is also given. For less than 1, f of x, a plus bx. Less than 1, f of x is a plus bx. For greater than 1, f of x b minus a into x. Correct. For greater than 1, f of x is b minus a into x. At x is equal to 1, the function is 4. This is particular value. F of 1 is equal to 4. This is very important. Particular domain, f of 1. F of 1 is 4. This is about the given function. This is about the given function. Observe here, we are finding the limit extends to 1 f of x. For left side, a plus bx. For right side, b minus ax. The conclusion is left hand limit as well as left hand limit, the functions are different. Correct? Is it same? No, the functions are different. So what we do? We are finding different values, means left hand limit as well as right hand limit. One more condition he has given. Limit x tends to 1, f of x is equal to f of 1. He has given limit x tends to 1, f of x is equal to f of 1. That implies. So I take for left hand limit. Okay, I take for left hand limit. So I write like this, limit x tends to 1 minus f of x is equal to f of 1. 1 minus means left hand limit. So we use the function a plus bx. Limit x tends to 1 minus a plus bx is equal to f of 1. F of 1 is what? 4. Correct? A plus bx. F of 1. F of 1 is what? 4. Wherever x, substitute 1. A plus b into 1 is equal to 4. One equation we got. Call it as equation 1. A plus b is equal to 4. Left hand limit is over. Understand? Left hand limit is over. Right hand limit. So left hand limit. So I write once again here, because we use this one. A plus b is equal to 4. Left hand limit. A plus b is equal to 4. Okay. A plus b is equal to 4. Similarly, second one. And right hand limit. And right hand limit x tends to 1 plus f of x is equal to f of 1. Limit x tends to 1 plus f of x is equal to f of 1. 1 plus b minus ax. 1 plus b minus a into x is equal to 4. B minus a into x is equal to what? 4. So substitute b minus a into 1 is equal to 4. B minus a is equal to 4. Call it as 2. B minus a is equal to 4. A plus b is equal to 4, 1. B minus a is equal to 4, 2. Our aim to find out the values of a and b. What we do? So we want the values of a and b. To find the values of a and b, solving equation 1 and 2. Correct? Solving equations 1 and 2. Okay, what we do? Solving equations 1 and 2. a plus b is equal to 4 minus a plus b is equal to 4. For 2, I add plus a minus a get cancelled. 2b is equal to 8, b is equal to 4. Correct? B is equal to 4. So we got one value. Substitute any one equation, either first equation or second equation. B is equal to 4, substitute any one equation. Since a plus b is equal to 4, that implies a plus 4 is equal to 4. A is equal to 4 minus 4. A is equal to 0. The values are a is equal to 0 and b is equal to 4. The values are a is equal to 0 and b is equal to 4. It is a very, very, very important problem. Observe the problem carefully. You also write it, you also practice it, then only you are understanding the concept. Next problem. Firstly, you observe this problem. Next problem. Next one. If f of x is equal to mod x plus 1, x is less than 0. 0, x is equal to 0. Mod x minus 1, x is greater than 0. What he asks? For what values of a does limit x tends to a f of x exits. This is very important concept. Observe here, for what values of a limit x tends to a f of x exits. Correct? Okay, given f of x is equal to mod x plus 1 for x less than 0. For x less than 0, 0 x is equal to 1, correct? And mod x minus 1 for x greater than 0. So f of x is equal to, we write once again, for less than 0, mod x is minus x plus 1, x is less than 0. 0, x is equal to 0. For greater than 0, mod is plus x, x minus 1 for x is what? Greater than 0. We rewrite once again the given function, correct? We rewrite once again the given function. Then, so we better to draw the number line. Minus infinity to plus infinity. The domain is 0. less than 0 the function f of x minus x plus 1. Less than 0 the function f of x is minus x plus 1. Okay. Greater than 0 the function x minus 1 at x is equal to 0, particularly 0, f of x is equal to 0. At x is equal to 0, the domain is fixed. Domain is fixed, range is also fixed. X is equal to 0, f of x is 0. What he asked, for what values of limit x tends to a, f of x exist. Okay. Firstly, we find 0. Okay. Firstly, we find 0. So, for left side, the function is minus x plus 1. For right side, the function is x minus 1. That means we are finding individual values, left hand limit as well as right hand limit. Firstly, we check out the domain at a is equal to 0. A is equal to 0. Limit x tends to a. So, left hand limit x tends to 0. X tends to a, in place of a I substitute 0. 0 minus f of x is what? Minus x plus 1. Minus 0 plus 1. Answer is 1. Answer is 1. Left hand limit is what? 1. Right hand limit x tends to 0 plus x tends to 0 plus function is what? X minus 1. 0 minus 1. Answer is minus 1. Answer is minus 1. Observe here, what is the conclusion? That implies left hand limit is not equal to right hand limit. Left hand limit is not equal to right hand limit. Is it exist? No. X tends to 0. F of x does not exist. Does not exist. Correct? This is one domain we at a is equal to 0. He asks for what values, correct? Limit x tends to a, f of x exists. The question is, for what values of a, limit x tends to a, f of x exists. At x is equal to 0. At a is equal to 0, limit value does not exist. We take less than 0. If I take less than 0, this side, what I draw here. Suppose minus 1, minus 2, minus 3, minus 4, minus 5. So for a less than 0, the function is minus x plus 1. Observe here, the function is minus. Suppose if I take at x is equal to minus 2. Left side is also minus x plus 1. Right side is also minus x plus 1. Limit value exists. Minus 3, limit value exists. Minus 4, limit value exists. Up to minus infinity, the function minus x plus 1, only one function, limit value exists. Because this is a polynomial function. This is a polynomial function. Every polynomial function, limit value exists. For greater than 0, if I take domain is 1, 2, 3, 4, up to infinity, the function for domain 2, left side is also x minus 1, right side is also x minus 1, limit value exists, 3 exists, 4 exists, less than 0 limit value exists, greater than 0 limit value exists, correct? Less than 0 means up to from minus infinity, limit value exists, greater than 0 means up to plus infinity, limit value exists. So the conclusion is, since f of x is a polynomial function, f of x is a polynomial function, less than 0 limit value exists, greater than 0 limit value exists, limit value exists from minus infinity to plus infinity. Minus infinity to plus infinity is nothing but what? Set of all real numbers. Set of all real numbers except one value does not exist, except what? 0. For what values of a? The what values of a limit exist? Set a belongs to r minus 0. Limit value exists. A belongs to r minus 0. A belongs to, got my point? A belongs to r minus 0. Limit value exists. We write only one sentence here, that is enough. We write, so limit x is 0, f of x does not exist. So I write here, that implies limit x tends to a, f of x exist for all a belongs to r minus 0. This is very important. Limit x tends to a, limit x tends to a, f of x exists for all a belongs to set of all real numbers. Or means what? Set of all real numbers except 0, because at 0 LHL is not equal to RHL. LHL is not equal to RHL means limit value does not exist. Limit value does not exist. So limit x tends to a, f of x exists for all a belongs to what? R minus 0. This is very important problem. Observe this problem. Next problem. Next problem. If the function if the function f of x, if the function f of x satisfies, if the function f of x satisfies limit x tends to 1 by evaluate limit x tends to 1 f of x. Different problem, simple problem. Evaluate limit x tends to 1 f of x means we are finding what? Limit x tends to 1, limit x tends to 1 f of x. Okay. If the function satisfies limit x tends to 1, limit x tends to 1 f of x minus 2 divided by x square minus 1 is equal to pi. This is given. This is given means, observe very important point, limit exists and it is equal to pi. That is limit value exists and it is equal to, correct, it is equal to pi. Limit x tends to 1, f of x minus 2 divided by x square minus 1 is equal to pi. That answer, this complete answer is pi means, this is given, that means limit value exists, and it is equal to pi. Limit value exists means this denominator is not equal to 0, that implies limit x tends to 1, x square minus 1 is not equal to 0. Why it is not equal to 0? Even though you substitute 1 minus 1, 0, 0, yes, but if it is 0, it is not equal to pi. It is not equal to pi. Denominator 0 means anything by 0 is infinity. Anything by 0 is infinity means limit value does not exist. Correct? That's why x tends to 1, x square minus 1 is not equal to 0. Because if this is equal to 0, limit value does not exist. Here he only given, it is equal to pi. It is equal to pi means limit value already exists. What my point? Limit value already exists and it is equal to pi. This is what limit x tends to 1, denominator is always not equal to 0. So numerator may be equal to 0. Limit x tends to 1, f of x. Numerator 0, no problem. Numerator 0, no problem. Okay, if it is 0, 0 by anything is 0, 0 is a finite value. It is equal to 0. Limit x tends to 1, f of x is equal to, f of x minus 2 is equal to 0. So apply this, that implies limit x tends to 1, x tends to 1, f of x minus 2 is equal to 0. X tends to 1, f of x minus 2 is equal to 0. Minus 2 you shift from left side to right side. That implies limit x tends to 1, f of x is equal to 2. So this value we want. What is the value of? Means compute or evaluate limit x tends to 1, f of x. For function we don't know. Limit x tends to 1, f of x is equal to 2. Very simple problem. Once again I explain. This is given, this is equal to pi. This whole value is equal to pi. What it understand? The concept is limit value exists and it is equal to pi. Okay, limit value exists and it is equal to pi means denominator is not equal to 0. What my point? The denominator is not equal to 0. Why it is not equal to 0? If it is equal to 0, so the value is infinity. The value is infinity indicates what? Limit value does not exist because he is exist and it is equal to pi. So denominator is not equal to 0. Numerator is equal to 0. No problem. It is a finite value. So x tends to 1, f of x minus 2 is equal to 0. Constant, it is a constant. Since if you want you write the reason, limit x tends to a constant, it is a constant. So minus 2. So minus 2 we shift from left side to right side. Limit x tends to 1, f of x is equal to what? 2. Understand? This is very simple problem. Next problem. Next problem, very important problem. If f of x is equal to m x square plus n. X is less than 0. N x plus m. X is greater than or equal to 0, less than or equal to 1. And x cube m. X is greater than 1. X is greater than 1. For what integers? For what integers m and n does both limit x tends to 0 f of x and limit x tends to 1 f of x exist. Limit x tends to 0 f of x and x tends to 1 f of x exist. This is very important. X tends to 0 f of x and x tends to 1 f of x exist. So this is given. Given f of x for x less than 0, from 0 to 1, greater than 1. Better I draw the number line, then only you are understanding very properly. First we see the function properly. Okay, we understanding the function properly first. This is from minus infinity to minus infinity to plus infinity. Domain is 0. Domain is 1. Two domains are given here. Observe here. X less than 0, the function is mx square plus n. X less than 0 means not include 0. Not including 0. This is very important. Not including 0. F of x mx square plus n. Mx square plus n. One more. From 0 to 1, x greater than or equal to 0. This indicates what? X greater than or equal to 0, less than or equal to 1. X greater than. Observe here. So dual inequality, we call it as this one. This one particularly we call it as dual inequality. X greater than or equal to 0, less than or equal to 1. X greater than or equal to 0, less than or equal to 1. So in between, from 0 to 1. So here two domains are included. From 0 to 1, greater than or equal to 0, less than or equal to 1, the function f of x nx plus m. Nx plus m. From it is from 0 to 1. This inequality we call it as, you know, in the linear inequality, dual inequality. Dual inequality. For x greater than 1, 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 f of x nx cube plus m. F of x nx cube plus m. Observe this graph first. Very carefully to observe. So for x less than 0, mx square plus n. In between 0 to 1, 0 is also included, 1 is also included, nx plus m. For greater than 1 up to infinity, f of x is nx cube plus m. What he asks, for what values of, what values means integers. He is asking integer. For what integers m and n does both the limit exist? If I substitute the values of m and n, x tends to 0, f of x also exists, x tends to 1, f of x is also exist. Firstly, we find at x is equal to 0, nextly we find at x is equal to 1. See, observe here, at x is equal to 0, observe the point, at x is equal to 0. Left side approach mx square plus n, right side approach nx plus 1. Left side mx square plus n, right side nx plus 1. For left hand limit and right hand limit, the functions are what? Different. Why I write this graph? Very easy to understand. Left hand limit mx square plus n, right hand limit nx plus 1. Both the functions are different. Both the functions are different means we are finding individually left hand limit as well as right hand limit. So firstly we find at x is equal to 0. At x is equal to 0. If you want, once again write the function, okay, f of x for only domain 0, f of x x is less than 0, x is greater than or equal to 0, x is greater than or equal to 0, okay. Left hand limit x tends to 0 minus function what? mx square plus n. Answer is n. Answer is n. Right hand limit x tends to 0 plus n into 0 plus m. Answer is m. Correct. Limit x tends to 0, f of x exists only when, under what condition? Left hand limit is equal to what? Right hand limit. Limit x tends to 0, x tends to 0, f of x exists only when left hand limit is equal to right hand limit. That implies limit x tends to 0, f of x exists only when, under what condition? M is equal to n. This is very important. Limit x tends to 0, understand? X tends to 0, f of x, limit x tends to 0, f of x exists. F of x exists only when what? M is equal to what? N. Limit x tends to 0, f of x exists only when m is equal to 0. At x is equal to 0 over. At x is equal to 0. He asks, for what integers of m and n does both the limit exist? If you substitute the values of m and n, x tends to 0, f of x is also exist, same value, and that means for same m and n, x tends to 1, f of x is also exist. Okay, so next, so what we do, we take at x is equal to 1. At x is equal to 1. We write once again the function letter f of x less than 1, less than or equal to 1, correct? Less than or equal to 1. Which one? Nx plus m. X is less than or equal to 1. Greater than 1. Nx cube plus m. X is greater than 1. Okay, so we find left hand limit as well as right hand limit. Left hand limit. Limit x tends to 1 minus. We use the function nx plus n. N into 1 plus n, not minus 1. Minus 1, 1 minus means this is the symbol we are finding left hand limit. We cannot substitute minus 1. Okay, n plus m. So answer is m plus n. Right hand limit. Limit x tends to 1 plus nx cube plus m. Nx cube plus m. Correct? Nx cube plus m. That means n into 1 cube plus m. Again it is n plus m or else m plus n. Okay, then that implies, same sentence we write here, limit x tends to 1 f of x exist only when left hand limit is equal to what? Right hand limit. Correct? Only when left hand limit is equal to what? Right hand limit. That implies limit x tends to 1, limit x tends to 1, f of x exists. Limit x tends to 1, f of x exists. Exist only when m plus n is equal to m plus n. M plus n is equal to m plus n. One more condition. Both the condition we are finding. Here m is equal to n. Here m plus n is equal to m plus 1. So we write the answer, both the limits. Suppose I take m is equal to 1, n is equal to 2. I choose the values, m is equal to 1, n is equal to 2. X tends to 0, f of x exists? No, 1 is not equal to 2. This does not exist. X tends to 1, f of x exists? Yes, 1 plus 2 is 3. 1 plus 2 is 3. So x tends to 1, f of x exists. X tends to 0, f of x does not exist for this value. M is equal to 1, n is equal to 2. Suppose if I take both the values are 1 and 1, m is equal to n is equal to 1. x tends to 0 f of x exists s 1 is equal to 1. X tends to 1 f of x exists s 1 plus 1 is 2, 1 plus 1 is 2. Both the functions are exist. Limit x tends to 0 f of x as well as limit x tends to 1 f of x exist. Correct? X tends to 0 f of x as well as x tends to 1 f of x exist for m is equal to 1, n is equal to 1. If I take m is equal to 2 and n is equal to 3, m is equal to 2, n is equal to 3. Is it x tends to 0 f of x exist? No, 2 is not equal to 3. X tends to 1, x tends to 1 f of x exist s 2 plus 3 5, 2 plus 3 5. Then for m is equal to 2, n is equal to 3, x tends to 1 f of x exist, but x tends to 0 f of x does not exist. If I take both the values of 3, m is equal to n is equal to 3. X tends to 0 f of x exists s 3 is equal to 3. X tends to 1, x tends to 1 f of x exists s 3 plus 3 6, 3 plus 3 6. By seeing these two results, we want both the limit exist under what values of m and n. By seeing these two results, you already understand limit x tends to 1 f of x as well as limit x tends to 0 f of x exist only when m is equal to n. Correct? So write the answer. Therefore, I write here, for what integers of m and n both the limit exist? Therefore, limit x tends to 0 f of x and limit x tends to 1 f of x exists only when m is equal to n. Correct? Limit x, both the limits x tends to 0 f of x and x tends to 1 f of x exist. X tends to 1 f of x exist only when m is equal to n I means what? Integers. For all m comma n belongs to I. Observe this problem. This is very important concept, new concept, very important concept. Observe carefully. So next problem. Next problem. Find limit x tends to 1 f of x where f of x is equal to 2x minus 3 x less than 1, 3x square plus 5x, x greater than or equal to 1, x greater than or equal to 1, 2x minus 3 x less than 1, 3x square plus 5x, x greater than or equal to 1. So we draw the number line. Very easy problem. The domain is 1. For the domain 1, less than 1, f of x 2x minus 3 greater than or equal to 1, including 1 also. x square plus 5x. Then what is the conclusion? If you approach from left side, 2x minus 3. If you approach from right side, 3x square plus 5x. Both the functions are different. Both the functions are different means we find left hand limit as well as right hand limit. When the limit value exists, if the left hand limit is equal to right hand limit. Okay, firstly, left hand limit x tends to 1 minus f of x 2x minus 3. So 2 into 1 minus 3, 2 minus 3. So answer is minus 1. Right hand limit x tends to 1 plus f of x 3x square plus 5x. The function is 3x square plus 5x. Substitute the values wherever x, substitute 1. 3 into 1 square plus 5 into 1, 3 plus 5, answer is 8. Then what is the conclusion? That implies LHL is not equal to what? RHL. LHL is not equal to RHL. Limit x tends to 1 f of x. X tends to 1 f of x. What? Does not exist. It is exist only when left hand limit is equal to what? Right hand limit. Limit x tends to 1, f of x does not exist. Observe this problem. Up to this, limit concept is finished up. Okay. So we start limits and derivative. We finish up limits. Limits topic is finished up. In the next class, we start derivative. Okay. Thank you. We continue the remaining concept in the next class.